Our next big deal is identifying the quadrant. Quadrant check. Quadrant check is absolute. It is never going to go away. Quadrant check is one of the bedrock rules of working with trigonometry. You must be able to do the quadrant check. Later on in the semester, we're going to be doing solving equations. If you do not know how to do quadrant check, you will not know how to solve equations. The end. Quadrant check is absolutely bedrock, basic, fundamental, minimal information. You must know how to do quadrant check. So, quadrant check comes from something we've talked about several times. I want to just sort of go over it again. This little memory device gives you all the information you need if you know how to interpret the information you've been given. This means all the functions are positive in quadrant 1. Sine is positive in quadrant 2. Sine and therefore cosecant. Sine and cosecant always have the same positive negative. Remember, the word is signum. So the signum of sine is positive in quadrant 2 and hence cosecant. Tangent is positive in quadrant 3. Therefore cotangent is positive in quadrant 3. Cotangent, tangent always agree. And then cosine, and hence also secant, is positive in quadrant 4. So, suppose we know sine of theta is greater than 0. We know sine of theta is greater than 0. What information do we get? We need to do quadrant check. So if sine of theta is greater than 0, what is the quadrant check? Well, look, if sine is greater than 0, that means greater than 0 means positive. Greater than 0 means positive. Well, that's what this means. Sine is positive in either quadrant 1 or quadrant 2. So this piece of information, by itself, this piece of information lets you know that you are in either quadrant 1 or quadrant 2. So far, that's all we know. Let's just practice that a little bit. Suppose we know tangent of theta is less than 0. Well, remember, this tells us, yes, this tells us everything's positive in 1, and it tells us tangent is positive in 3. But it tells us more than that. These are the only two quadrants where tangent is positive. If tangent is positive in 1 and 3, this also tells us it is negative in quadrants 2 and 4. Tangent is negative in quadrants 2 and 4. Less than 0 means negative. Greater than 0 means positive. Less than 0 means negative. Greater than 0 means positive. Tangent theta less than 0 means tangent of theta is negative. In what quadrant? Well, tangent is positive here and here, so that means tangent is negative here and here. Right? Tangent is negative here and negative here. So, if all we're given is this piece of information, then we would know that we are in either quadrant 2 or quadrant 4. Again, I write my Roman numeral 4s like this. Whenever I write Roman numeral 4s like this, I make my Roman numeral signs and these start to look like 3s. And so to avoid that and a few other reasons, I always write my Roman numeral 4s this way. So I will always do that, and that's how I do it. That ship has sailed, that's the way I'm going to do it. So if all you're given is this, then you know you're in either quadrant 1 or 2. If all you're given is this, you know you're either in quadrant 2 or quadrant 4. This can be given, any piece of information of this variety tells you this much information about the quadrant. So let's do a couple more here. Suppose we know secant of theta is less than 0. Here's number 1 we'll have you do. And number 2, let's do sine of theta is less than 0. So maybe pause the video and see if you can work out these quadrants, and then we'll come back and check to see if I can match what you did. Okay, let's see if I can match up your work. Secant, remember that secant always obeys the same rules as cosine in terms of the positive negative. Secant is the same as cosine. We want secant less than 0, which means we want secant to be negative. Cosine, and hence secant, is positive here, therefore it's negative here. So from this information, we know we're in quadrants either 2 or 3. So we're in quadrant 2 or quadrant 3. And then same song, next stanza. We want sine to be less than 0. This is where we want sine to be negative. Well, sine is positive here, so sine is negative here or here. So that means that we're in quadrant 3 or quadrant 4. We're doing quadrant check here, or. So this is or. We don't know which one. If all you're given is this piece of information, this is as much as you can say. However, what's going to happen is we are going to be given 2 pieces of information. So we're going to be given that secant of theta is, let's say, greater than 0. And we're given that tangent of theta is less than 0. So maybe we're given that piece of information. 2 pieces. So this tells us it's these 2 or this one or this one. This tells us that one or that one. And then we want to know where both of these take effect. So this is pretty straightforward. Where is secant? Secant greater than 0. Remember, secant agrees with cosine. Secant is greater than 0 means cosine is positive. That means we're here or here, right? One of those 2. So far we have one of those 2. But now we also know tangent is less than 0. Where is tangent negative? Well, if it's positive here and here, that means it's negative here and here. So it must be either 1 or 4, and it must lie in either 2 or 4. We want both, right? And means both. So where is the only quadrant where both of these take effect? Well, that's quadrant 4. So given 2 of these, we can always deduce the quadrant, and we have done the quadrant check. Sometimes all you're given is 1, and your quadrant check is you have 2 options. Sometimes you are given 2 of these pieces of information, and you can deduce from them what single quadrant the value of theta must fall in. And so that should be pretty straightforward. Given any 2 of these, you should be able to deduce what quadrant we're falling in.